Hello, I'm Oliver Gao. I'm the director of Cornell System Engineering Program. Today, I'm very honored and pleased to have our guest, Professor Melanie Mitchell. And she's a professor of computer science at Portland State University, an external professor and a member of the science board at the Santa Fe Institute. She's author or editor of 5 books and over 80 scholarly papers in the fields of artificial intelligence, cognitive science, and complex systems. Wow, that's a very wide spectrum of the coverage. So welcome, Melanie.
Thank you.
So thank you for making the trip to visit us, especially now today's weather is kind of all in a sudden getting cold.
Yeah.
So I would like to start probably maybe you want to talk about yourself and your research in general so that people get a better understanding of what you do and who you are.
Well, okay, I'm interested in a lot of things, but these days I'm mostly interested in intelligence, both artificial and natural, and how it can come about in a variety of systems, not just humans or animals, but also in other kinds of complex systems. And I'm in the midst of writing a book about artificial intelligence and trying to explore some of these ideas.
That's great. So you mentioned you do a lot of work. It sounds like one keyword I pick up is intelligence, whether it's natural intelligence or artificial intelligence.
Right.
And I think speaking of artificial intelligence, now it's definitely I think probably the most kind of buzzword.
Yeah.
And also that kind of I think it's really an area that not only academics very interested in, but also look at what is happening in the industry.
Oh yeah.
Right.
More
So much
even.
power and so much investment behind it. But I really like the angle you have been looking at artificial intelligence because as you mentioned, you are not just looking at artificial intelligence, you are looking at artificial intelligence and the natural human intelligence. And also of course in between, and I think one keyword that linking this AI and human intelligence, and I feel like when I was reading the abstract your talk, you mentioned the word meaning.
Yes.
So what's your view about the relation between AI, humans, and meaning?
Well, this is the mystery of intelligence, is that when we, as humans, for example, deal with concepts, use natural language, perceive the world, we have the sense that it means something to us.
That's
we
right.
have a lot of, we can take the knowledge we have about something, we can use it in other domains, we can transfer it, we can make analogies, we can bring to bear our prior knowledge and expectations on new situations. And it's been very surprising. In the old days, people tried to program that directly into computers, to expert systems, rule-based systems, what people called symbolic AI.
That's right.
But nowadays, the most successful approaches are machine learning approaches, which basically learn everything from data, and everything is sort of encoded as the statistics of very large data sets. So it's been very surprising to me that that kind of approach can actually be so successful. For example, in speech recognition or
That's
visual recognition, and it seems like these systems don't capture the kind of meaning that we have. So what I'm trying to explore, especially in the talk today, is the kind of meaning that we think we have, is that important for intelligence? Can we have intelligence without it? And what kinds of sort of problems does the lack of meaning show up as in modern AI? And there's some problems that these systems have, including making very non-human-like errors, being unreliable, and also being vulnerable to attack in ways that human intelligence would not be. So I'm going to look at that and say, how much does the lack of understanding, in the sense of we think of, create such problems?
So of course, when we talk about meaning, and then you brought another word, learning, right? I think imagine like when we were like 2-year-old and then 20-year-old, as we grow into adulthood, and that the key difference that made between 2-year-old and 20-year-old, that makes a difference is basically the learning. Learning, and then through the learning, and then we probably give things and associate things with more meaning. That's probably a sign of we growing up, right? And when we talk about learning, of course, again, like you have natural AI and human AI, there is learning. There is also kind of natural learning, and like machine learning.
Yes, and it's very different.
It's very different. So I'm just thinking kind of like as a layman to this AI, as a general public. Remember when we first had just not a computer, just a calculator, right? A calculator is somehow doing the calculation, doing this kind of multiplication or division, right? While humans, we learn how to do this multiplication and division, but apparently, for example, when we do just simple addition, 1 + 1, and then probably the human learning kind of surpasses that kind of calculator. However, when we go to the larger numbers, and definitely the calculator will do a better job than human. So now having an analogy, machine learning and human learning, and I know like kind of learning in the end will hopefully lead to resolve the problem of meaning. So in that sense, imagine 10 or 20 years later when artificial intelligence has been developed so advanced. So what things are going to be remain for humans for us to feel superior?
That's a good question. So nobody really knows, but I think the question is, like, in 10 or 20 years, sort of how far is it going to go? We see this trajectory where, AI seems to be advancing extremely fast, right? And it in some areas it has. So in areas of like speech recognition is one area. Another is like game playing. We see this incredible AlphaGo beating the world's best Go players. In other areas, it's the speed of progress is much slower, however. So, for example, in what people call natural language processing, for example, answering questions, being able to carry on a conversation. AI is not so good at that, as we can tell from if you ever try and use, say, an assistant on your phone, use Siri or one of the Amazon Alexa. It's not that good yet at being able to really understand what we mean when we're talking to it.
That's right.
And people can see that very clearly, but if they interact with it. And the question is, why is that so much harder than something like speech recognition, object recognition, game playing? And I think that one of the problems is that when we use language, when we talk about things in sort of a free form, humans have a lot of background knowledge that we know about.
That's right. That
these systems don't have. It's very hard for them to learn it because it's not written anywhere. So, one example, this is an example I like to use, IBM Watson. Remember that program that played Jeopardy?
Yes. Yeah.
If you asked it, how many gold medals did Mark Phelps win in the Olympics? It can tell you. Good. Right. But if you ask it something like, when he got out of the pool, was his hair wet? That doesn't appear in Wikipedia anywhere.
That's right.
Right, that kind of sort of knowledge about how the world works, or when he was swimming, was he wearing socks, or things like that. And it may seem like that's sort of a trivial thing, we can answer all those questions, but who cares? But it turns out that kind of background knowledge comes up all the time in understanding language. And that's one of the reasons that these systems can't really communicate well with us or understand what we want, because they don't know how the world works. And so a question is, how do we get the kind of world knowledge that, say, a 2-year-old probably has just by having lived and experienced in the world? How do we get computers to have that kind of knowledge?
Yes, I think one thing that is like humans were different from AI is that, of course, I think at one element, in one dimension, it's really the meaning, and the meaning that we can associate to anything versus the meaning that a machine can associate. And another thing I feel, for example, when you talk about asking a question about medals Mark received versus whether his hair was wet or not, and then the machine won't be able to answer. That kind of reminds me that in humans, we're not only kind of giving meaning to things, but also the reason why our society has been able to advance is because of imagination. Right. So from observation, and they can imagine something that didn't exist before.
Yeah.
However, can machine, if they cannot imagine, so that probably gives them a limit. And speaking of that, I think as researchers, actually we turn to researcher or scientist. So many things in practice that are happening, but but for the job part, we don't really know where things are going. However, theorists, mathematicians, they can formulate this problem into in kind of very well defined theoretical problem, and they can derive theoretically where the limit is going to be. So in that sense, is there any study that has looked into, for example, the limit of AI?
That's kind of a controversial point, actually.
It's controversial.
Yeah. So some people have claimed that true AI, human level AI, is impossible because of certain limits on computation. Sort of the Turing universal computation kinds of limits, which are in sort of theoretical computer science.
Yeah.
Other people, including myself, don't agree with that. But there is a lot of question about what can computers actually do, and how do our brains work? We don't understand, the limitations on our own brains. So it's a little bit hard to say. That are our brains just computers, or is there something more, that we can do that computers can't do? I tend to think that we are computers, essentially.
Yes.
That there's nothing that we can do that a computer in principle couldn't do, but we don't know how to make them do it. So I don't know what the limits on AI are, and I don't know what the limits on our brains are. I think the two are related.
Yes, they are related. That's kind of so reminds me, because I think AI, machine learning, because one key element for learning is really the storage of memory, and also the speed of calculation, which I don't think human brain can beat the computers nowadays. Right. However, in addition to to memory and storage, another part of learning that again relates to the creativity, right? So in that sense, I agree with you. I believe there's nothing that a computer cannot do if a human can do it. However, do you see if there is going to be a lag? Like AI, they will eventually be able to do whatever humans are able to. However, there is a lag. First, humans create and learn to do something, and then they teach or they program the machine to do that. Or do you think that machines can always do what humans can? Is there any possibility that machines could surpass?
I think it's possible.
It's possible,
but I don't.
In certain aspects.
Obviously, machines already surpass us in many aspects, as you say, like
yes.
doing calculations and so on. And we know that they can play chess better than we can. They can play Go better than we can. They can do lots of things, but they're narrow. The AlphaGo can play Go extremely well, but it can't do anything else.
Exactly.
And that's a big issue, is how do we get machines that can be more general like us, that can take what we know about one domain and use it in a different domain, and take what we've learned and apply it to other domains. We seem to have some very general mechanisms for using concepts. If I learn to play Go, I can also sort of make analogies between Go and maybe other games or maybe other aspects of life even.
That's right.
And machines can't do that yet. That's a very big part of our creativity and our imagination, is this ability to sort of map knowledge from one domain to another.
That's right.
So that, I think, is a big open question for AI. How do you get that kind of ability?
I see. So actually, this, I had a question later, but now I kind of, based on this conversation, I would like to bring up this question a little bit earlier, because while I was reading your website, and I noticed you had an SF grant, which is called C28.
Yes.
Yeah, that an integration of deep networks and analogy making for situation recognition, and in that abstract, and I really like the way you put it. Yes, situation recognition, this capability, while no computer vision system yet comes close to capturing these human abilities, for example, in terms of situation recognition. I find that project really fascinating. Do you want to talk a little bit more about that project and what you found out?
Yeah, so as I mentioned, the computers can now do very well at recognizing individual objects, say in photographs. But humans, when they look at a visual scene, for example, they recognize a whole situation. Like, I see this is a faculty office, or in the examples that I gave in like on my website and so on, we see somebody walking a dog. We know a lot about that kind of situation. We know that we have expectations of where the objects are, what their relationships are to each other, why they're doing it, what sort of the goal of the activity, if we saw it in a video frame, we could probably predict what was going to happen from frame to frame. We just come with lots of prior expectations, and that helps us understand what we're perceiving. And if there's some kind of very new situation that we encounter, we can use our prior knowledge about the objects of the new situation to try and understand it in terms of situations that we've already understood. So that's where the analogy comes in. So we're building a system called Situate, as you said, that is attempting to interpret visual situations, namely collections of objects and relationships between objects and attributes and actions that are sort of more abstract concepts to us. And that's an very important thing for computer vision.
Yeah, so yes, computer vision, it does have some limit, but however, I think both of us, we agree that, machines, they can always learn. And in terms of learning, how does a machine learn to understand and reason about the images and the natural language?
How does it learn to reason?
Yes, how do they learn to, because we in the end we say the meaning, and how does a machine learn to give meaning to something and learn to reason about images or natural language?
That's very difficult. I mean, that's something that I think is what everybody is essentially working on.